Hello, everyone. This is an extension on our discussion on empirical and molecular formulas. In this video, we will be determining the molecular formulas of compounds based on their percent composition by mass. So as a review, we have molecular formula denoted by capital letters MF, which is derived from empirical formula and the molecular mass. The molecular mass is obtained independently and experimentally. Now take note that if you talk about empirical formulas, then it gives us the smallest whole number ratios of the element, while for molecular formula, we find a multiplier, okay, or a whole number multiple x, which is basically the result if we divide the molecular mass of the sample with the empirical formula mass. So a key point here is we need to attain the correct empirical formula mass given the percentage composition. So as usual, we start with an example, caffeine, which is a known stimulant. Okay, so if ever you feel sleepy, okay, you take a cup of coffee. Again, and that coffee is the active ingredient in coffee is caffeine. Okay, so caffeine is made up of 49.5% carbon, 5.20% hydrogen, and 28.8% nitrogen and 16.5% oxygen. So this is an organic compound, and so you see a handful of elements there. Now its molecular mass, okay, which is given is 194.10 grams per mole. Now we are asked to find the molecular formula. So our first step is actually to get the empirical formula of the compound, and then we have to calculate the empirical formula mass, okay, the way we did with molar masses. And then we have to find the multiplier, the whole number multiplier, which is the molecular mass divided by the empirical formula mass. And then we have to distribute the multiplier x to the subscripts of the empirical formula to get the molecular formula. All right, so we'll deal with this example on caffeine. So in here, we already have some preliminary steps in order to save time. So again, the first step for getting the molecular formula is actually obtaining the empirical formula of a compound. And before we can get the empirical formula, we still have to get the number of moles for each particular element. So in here, we will be getting the number of moles for each element. So we can cancel grams of carbon, we can cancel grams of carbon. So we end up with the number of moles for carbon, which is 4.122 moles of carbon, right? And then after that one, we have grams of hydrogen. So we can divide the unit of grams. So we end up with 5.20 divided by 1.01. So we'll have 5.149 moles of hydrogen, right? And then nitrogen also, the unit of grams will be cancelled out. So we'll have 2.056 moles of nitrogen. So again, what we are doing here is getting the number of moles for each element, okay? So that we can obtain the empirical formula. So if you haven't seen yet how the empirical formula is obtained, kindly go to the previous video on EF. So 1.031 moles of oxygen. So after getting the number of moles for each element, we divide it with the smallest number, which the smallest value, which is 1.031. Okay, so we divide everything with 1.031. Then divide everything with 1.031. So this is quite a handful molecule because it has uh, four different types of element. Okay, so after getting, okay, after dividing everything with the smallest number of moles, then we can get the mole ratio. So 4.122 divided by 1.031 gives us a result of 3.99. Okay, and we may round off there, so this is approximately equal to 4, right? And then for hydrogen, we end up with 4.99. So if you have your calculators with you, can do some checking, double checking. And then this is approximately equal to 5 already. So now we have 4, 5, and then this is 1.99. 2.056 divided by 1.031 is 1.99, which is approximately equal to 2. And then we have, of course, 1 here. Now, therefore, we have the following mole ratios, and there is no special case. There's nothing that we have to multiply by 2. There's nothing that we have to multiply by 3 or 4. So, for our empirical formula, then we have C4, H5, N2, and then O. Okay, so that is our smallest whole number ratios for each element in our empirical formula. Now, how do we find the empirical formula mass? Okay, so we are going to find the empirical formula mass by just adding, okay, the different masses for each element. So, for example, for carbon, you have 4 atoms of carbon, and we know that the atomic mass of carbon is 12.01 AMU or mu. So we can place that here. Then it's just like getting your molar mass. So this is hydrogen. There are 5 atoms of hydrogen. This is 1.01 AMU. Okay. And then nitrogen has 2 atoms. So we'll have 14.01 mu. And then oxygen has 1 atom. This is 16.0 mu. Okay, so once you add everything up, this will result to the empirical formula mass, which is equal to 97.11 AMU or mu, or we can just go directly to grams per mole. Okay, so this is our empirical formula mass, the mass from our empirical formula. Okay, after that one, we have to find our multiplier x, the whole number multiple, which is equal to the given molar mass, okay, divided by our empirical formula mass. So we will have our given molecular mass is 194.10 grams per mole, and we divide it with our EFM. So this is 97 divided by 97.11 grams per mole. Notice how we can cancel our units on grams per mole so that we end up with a unitless multiplier. So our x is equal to 1.99998, right? And then this is already approximately equal to 2. So we will just round it off to 2. Therefore, our multiplier, we have to distribute it to the empirical formula to the subscripts of the empirical formula, such that in getting the MF, we now have, okay, our final answer finally is C8 H10 N4 O2. And therefore, the caffeine molecule is made up of 8 atoms of carbon, 10 atoms of hydrogen. This is only one molecule, okay? We know that for each substance, they're composed of so many molecules. So 10 atoms of hydrogen, 4 atoms of nitrogen, and then 2 atoms of oxygen. So that's C8H10N4O2. That is caffeine. All right, so as a review, we get the empirical formula here. We get the empirical formula mass, and we get our multiplier x, and multiply the multiplier to our empirical formula, so that we end up with our molecular formula. Now let's deal with another example on molecular formula. So if we are very lucky, we will have problems wherein the empirical formula is already given, such as this one, beta carotene. So beta carotene improves eyesight and is commonly found in leafy vegetables, okay, carrots, and etc. So the empirical formula is C5H7, and the molecular mass is 536 grams per mole. Now we are asked what the molecular formula is for the compound. So in here we are already given the empirical formula, which is C5H7. So if you remember, the next step, if you already have your empirical formula, is to get the empirical formula mass. So our EFM. Okay, so that means we'll have to account for carbon and we'll have to account for hydrogen. So this is 5, and then that's 12.0 atomic mass units, or mu, and this is 7, that's 1.01 atomic mass units. Okay, so that's 5 times 12.01 plus 7 times 1.01. Okay, we have a total of 67.12. Then mu, atomic mass units, or we can just report this directly as our grams per mole, right? We know that they are numerically equivalent. Now that we have our EFM, all we need to do is to find our multiplier, okay? Again, it is equal to the molecular mass, mm, divided by our EFM. So we are given the molecular mass of 536 grams per mole, and then we have identified our EFM to be 67.12 grams per mole. So therefore, we can just divide directly. So that's 536 divided by 67.12. So our answer here is 7.99, okay, 985, which is already or approximately equal to 8. Okay, therefore our multiplier is 8, which we can distribute to the subscripts of our empirical formula. So if our empirical formula is C5H7, then our MF molecular formula is equal to C40 H30 H56. All right, so that's 5 times 8 is 40, 7 times 8 is 56. Therefore, we have now our molecular formula. All right, so those are the steps in getting the molecular formula. Now it's your turn. Okay, you try this one out. Cholesterol. Okay, so this is the one if in excess we have cardiovascular problems. Okay, so that's why we have to minimize eating fatty food, right? So in here we have a cholesterol-like substance or compound which has a molecular mass of 386 grams per mole and is composed of 84.0% carbon, 11.90% hydrogen, and 4.10% oxygen by mass. So, I'd like you to find its molecular formula. You may pause the video and have your solutions on a piece of paper or on your notebook. So in here, we have the same process. We need to find the empirical formula of cholesterol. So right now we are actually in the calculation of the number of moles step. So the next thing to do is to divide everything with the smallest number of moles. And our smallest number, as you can see there, is 0.256. So we are going to divide all these values with 0.256. All right, and so we have the following molar ratio for each of the elements. So for carbon, we have 27.32, so it can be rounded off into 27. Now you have for hydrogen, it's 46.02, so it can be rounded off into 46. And then for oxygen, we have 1, right? Therefore, our empirical formula, our EF, for the three elements, or for cholesterol, the cholesterol-like compound is C27H46 and then O. Alright, now our empirical formula mass, so I leave it up. I hope that you have it in your solution. Okay, I'll just go directly. So that's basically 27 times 12.01 plus 46 times 1.01 plus 16. That is equal to 386.73, right? That's grams per mole. Now, you might have noticed that you ended up with more or less the same value as the given molecular mass, which is fine, right? Don't worry about it. So therefore, if you get your multiplier, that's our given molecular mass in the problem, divided by our EFM. So more or less, you are going to have, okay, that's 386 grams per mole divided by 386.73 grams per mole. Now we can cancel the units, and our answer here is 0.998, which is practically equal to 1 already. Okay, and therefore our molecular formula, okay, happens to be the same with our empirical formula. So that's C27 C27H46O. Alright? So again, empirical formulas and molecular formulas can sometimes be the same, uh, depending on how much of the masses are given. Alright? So a few moments to reflect for the cholesterol-like compound. So our answer here is C27H46O, right? Now you try, okay? This time it will be on your own, and I do hope that you can answer it on your own as well. So a compound with molecular mass of 60.0 grams per mole is found to contain 40% carbon, 6.7% hydrogen, and 53.3% oxygen. What is the molecular formula of that compound? Okay, so pause this video and try to work out your solutions. I'll be asking you maybe later on to present your solutions. If your answer is C2H4O2, then congratulations, you got the right answer. Okay, so ladies and gentlemen, that was molecular formula. So until next time.